Hi everybody, today is Wednesday, October 12th. This video might be just a little bit longer than what we're used to. I'll still try and keep it under 10-15 minutes. But I want to go through all of the slides today for the slideshow because if you missed class today, you really missed a lot. And those people who want to review, we really did a lot today. So let me go ahead and take you through it. The first activity we did was there was a warm up and just a letter from Dr. Moraga asking if we can help decide what type of plate boundaries between the plates where Mesosaurus fossils are found. And so the kids just took a minute to write their ideas down. We talked about it a little bit, and then we moved on. Remember, we are investigating the question, what happens to the plates and the mantle at plate boundaries? Today we're going to reread a few sections of the article, Listening to Earth. So if you were in class yesterday, you have this. If you don't, if you were not in class yesterday, go back to yesterday's folder, get a copy of Listening to Earth, and put it in Good Notes. And then I want you to read it and annotate it, and then come on back. Okay? All right. I also want you to know that because we're rereading, I'm really going to highlight some aspects of the article, some two paragraphs particularly. And so you may need to make additional annotations if you didn't have this written down already. When you turn in your revised annotations, I'm specifically going to be looking to see if you included this information. And if you didn't, then you're not going to get the points that you would have if you did. All right. The reason why we're rereading is because in a little bit, I'm going to give you this plate boundary comparison chart, and the additional annotations will help you prepare to work on this chart later on. So let's start by numbering the paragraphs. Go through and number all your paragraphs. We've got paragraph number 1 and number 2 on the first page, and then 4, 5, and then just ultimately there are 8 paragraphs. So I also want to preview some new vocabulary words that we're going to see in the 2 paragraphs that we're going to be looking at. You will have read about a trench, and if you remember, we looked at a channel in the Geology on Mars, which was our previous unit. A channel and a trench are different. A channel was a long, narrow groove, and a trench is a long, deep indentation in the ocean floor formed when 2 plates move together. Another vocabulary term that you'll see is volcanic activity. And this is any of the many processes, such as eruptions and lava flows, in which gas, lava, and ash are pushed out onto the surface of Earth. And then lastly, we'll read about a mid-ocean ridge, and that's an underwater mountain range formed when 2 plates move apart. All right, so if you will go ahead and turn to paragraph 4, it's on page 2, and I went ahead and I highlighted the vocabulary words that we see in this paragraph. So you've got convergent, boundary, plates, mantle, there's trench, earthquakes and volcanic activity. Earthquakes we had a couple days ago, and then this is the first time we're really talking about volcanic activity. So I'm going to show you some annotations. If you don't have them, I'd like you to go ahead and do that. First thing is I want you to underline or highlight the definition of a convergent boundary, and that's when 2 plates are moving towards each other. The collision is very slow, and I highlighted this part because it reminded me of the pre-unit assessment. Do you remember in that pre-unit assessment, the very first short answer, there was Diego's brother. He was freaked out because he was worried that these continents are going to crash. And in reality, what it's saying here is the collision of the 2 continents coming together is very slow. And so I want you to notice that when the 2 continents come together, they do not crash. They get pushed together slowly, but there is no crash. Okay? As they're getting pushed together, the plate that's on top can bend and fold. And I wish you were in class and I wish I had a way to show you what I mean. But the plate that's on top is going to kind of crinkle, and there's actually going to be like a buildup of plate on top of that. So the top plate actually tends to get a little bit thicker. You could have mountains being formed in this way. So the plate that's on top bends and folds, and the plates on the bottom is shoved into the mantle, bending downward and forming a deep trench in the boundary. If you remember what we do with our hands at a convergent plate boundary, we put one hand underneath the other, and there's that V that we create with when our fingers are touching the knuckles of the one that is going underneath it. That V, that really deep V, is a trench at the boundary. So it's much deeper than a channel. It's very deep. As the bottom plate sinks into the mantle, what happens to it? It is destroyed and it becomes part of the mantle. I wanted you guys to put a box around the word trench, and then I want you to go ahead and add in the margins an annotation where it says the landform is a trench. Trust me, this is going to come in handy for you later on. So at convergent plate boundaries, one of the ways that we can tell if something is convergent is because we look for a trench. If you see a trench, then you know that is an indication that it is a convergent plate boundary. Okay, so again, as the bottom plate sinks into the mantle, it's destroyed. It breaks apart. It's mixed in with the soft, solid rock, the magma that's underneath the Earth's outer layer. And so it starts to break down. It is destroyed, and it actually becomes part of the mantle. And then both earthquakes and volcanic activity are common at convergent plate boundaries. Good to know, very important to know. It's a distinction between when we go to compare and contrast between convergent plate boundaries and divergent plate boundaries. These things that I've highlighted, that I've put boxes around, this is a really easy way for you to identify this one's convergent. Okay? All right, so now look at paragraph number 5. This one is talking about divergent plate boundaries. And so again, I've highlighted in a different color the vocabulary words that we're looking at. You've got divergent boundaries. We've talked about plates. We've talked about mantle. And then down at the very bottom, new vocabulary word is mid-ocean ridge. So as you read through, it says Bob Dezak and his team don't just listen to the ocean near convergent plate boundaries. They also use their hydrophones to listen in on divergent boundaries. Divergent boundaries are the opposite of convergent boundaries. They're places where two plates are moving away from each other. As the plates move, hot material from the mantle comes up to fill the space between them. The hot mantle material cools and hardens and adds new rock to the edge of each plate. Over time, these additions of rock form a mountain range made up of long chain of volcanoes. When this process happens on the ocean floor, scientists call the landform an ocean ridge. Mid-ocean ridges can be thousands of kilometers away. All right, so go ahead and put a box around mountain ranges and volcanoes. And I want you to write down that we've got a mid-ocean ridge. That's the landform. Does it say that there's volcanic activity here? It does not. It says there are volcanoes, but no volcanic activity. That's important to remember. All right, so now we're going to be using the plate boundary comparison chart. This is in Schoology, so go ahead and take a minute, copy this into GoodNotes, and then come on back to the video. The plate boundary comparison chart is going to help you organize your thinking about similarities and differences between convergent and divergent plate boundaries. And we're going to be using this over the next few lessons. So it's really important that you take your time and that you fill this out really, really well, as completely as you can. You go ahead and use the article that you reread today as your source of evidence to complete the chart. We'll definitely use it tomorrow. When you are finished with that, I want you to hand in your revised annotations. So really, I'm just looking at paragraph 4 and 5. Just hand in that one page. Okay? If you have a digital copy, you're going to do listening to Earth annotations. Now, if you were here yesterday, you have a hard copy and you want to show me that, just wait. I told the kids to leave it on their table and I walked around and graded them. But you can either take a picture of it if you want to and send it to me, submit that on Schoology, or you can show it to me when you get back to class. Lastly, we've got an exit ticket. The exit ticket is to write a response to a digital thread on Schoology. And the question is it's 2 parts. So make sure that you answer both parts. First of all, how are convergent and, that should say divergent, plate boundaries the same? And then tell me how they're different. How are they the same and how are they different? Please do not say one is this and the other is this. You need to tell me which one is which. Okay, this is a way for you to review what you've learned and make sure that you understand what you're talking about. All right, you guys, that's it for today. Take care and hopefully I see you tomorrow.